Okay, I'm trying to create a video so that I can still help you review because my voice is not really that good. I will try my best to explain um, most of the important questions that is in your review. Okay, just a note, the things that I will not be discussing. Let's say, for example, number one, you can just look at your ISN page 40. We discussed this one, we have the concepts about that one. And then also number 7, ISN page 40 as well. Okay, if you don't remember what is on ISN page 40, it's this one that describing a pendula. We discuss at which point these physical quantities are maximum or minimum. If you do not have the answer to it, these are the things that we've discussed on that one. Okay, so I will try and start with the first number, the second number. For number 2, what length of the string is required to have a pendulum with a period of 2 seconds? So we have a period, we need the length, and it is a pendulum. We know that the pendulum is swinging back and forth. The equation that we know that is relating this one is the t equals to 2 pi square root of L over G. This equation is in your formula chart, but it will not hurt if you memorize it. And we need the length, okay? But before we do that one, we know that this L is in the square root, so we need to cancel that square root first, okay? But actually before that one, let us divide both sides by 2 pi first. It really doesn't matter. And then after that, get the square root, get the square, and then we will end up with our equation t squared over 2 pi. Actually, this is in the whole parenthesis, and then the square root in L and G will cancel. Then rearranging further, okay? And then when you plug in the values that we have the period of 2 seconds, and then G is 9.8 meters per second squared. Caution when you're using the TI calculator, this 2 pi should be in the parentheses, and then if you plug in everything, your answer should be letter B. Okay, next, number 3. Okay, I will put number 3 right here. A position of 0.64 mass undergoing a simple harmonic motion is given by x equals to 5 cosine pi t over 4. What is the frequency of oscillation? Okay, when you have this equation, this one is similar to the general equation of the simple harmonic motion as x equals to a cosine omega t. Okay, and the equation that is given to us is this one. X equals to 5 cosine pi t over 4. Okay, based from that one, we can say that A is 5, and then T is T, and the omega is pi over 4. Okay, and when we need a frequency, there are two equations of angular frequency or the angular velocity omega, in terms of the frequency or in terms of the period. Okay, but we need the frequency, so we gonna use this equation. So omega is 2 pi f. Our omega is pi over 4, and that is equivalent to 2 pi f. If you calculate for f, your answer should be 0.13 hertz, which is letter C. Next, number 4. Two oscillating system, spring mass and a simple pendulum undergo simple harmonic motion with an identical period t. If mass in each system is tripled, which of the following is true about the new period? Okay, so I'll write number 4 here. This one and this one is the spring and the mass system. We know that the period for the spring system is t equals to 2 pi square root of m over k. And then we just discussed in the pendulum it's 2 pi square root of L over G. And based from this one, if we're going to change the mass by 3 times, we know that the pendulum is not affected by the mass because we do not have mass here. So we can already cancel letter A because the pendulum will not change. So it's either B, C, and D. And we know that the mass is affected or affecting the period of the mass spring system, so it means this one will not be true also. So now what will be the new period of the mass spring system? So if the mass spring system is 2 pi square root of m over k, and we triple the mass, so you see it will increase by square root of 3. So therefore, our new period is 3 multiplied by the t. Okay, number 5, and by the way, number 5, just look at your ISN page 40 as well. You will see when is the restoring force and acceleration maximum. Okay, number 6, a student observed that the pendulum swings at 10 cycles in 9 seconds. What is the period? Okay, I was always asking you about this one. What is a period? Period is the time per cycle, one complete cycle. So here, if we do have 9 seconds, and it will make 10 cycles, it means if you have 9 divided by 10, that will be 0.9 seconds in a cycle. So our answer is letter D. Alright, next, number 8. An object oscillates at the end of the spring. The position as a function of time is presented by the graph. Which of the following equation represents the position of the object as a function of time? So again, this one is a simple harmonic motion. And we know that the general equation for the simple harmonic motion is this one. And we know that the x and the t never change. Not really never change in the equation because the x and t is dependent of each other. As you are changing the time, the x is changing. Okay, so now based on the graph, let us write down the equation that we have here. Okay, so for our A, we know that if we measure the amplitude, it will be this, right? And the amplitude would be equivalent to 1. Okay, now the omega. What is an omega? Again, omega can be 2 pi f, or omega can be 2 pi over t. It really doesn't matter, whichever you prefer. Frequency is the number of cycles in 1 second. And if you can look at this one, in 1 second, how many cycles do we have? Only half of the cycle. So it means our frequency would be 2 pi times half, right? And 2 times 0.5 is 1 multiplied by pi, because we have the pi there. If you use this equation, it will be the same thing. 2 pi, and what is the period? Period is the time for 1 complete cycle, and our 1 complete cycle is from here going here, which will take how many seconds? 2 seconds. And if you have that one, the 2 will cancel, and then you will have pi. So it will be the same thing. So it means our omega would be pi. And then if we just plug this in this equation, we know that this is equivalent to x, A is 1, cosine, our omega will be pi, and then the t will be there. So the answer would be letter C. Okay, number 10. A black light you purchase produces light with a wavelength of 4.5 times 10 to the 10 times 10 to the minus 7 meters. So this is our wavelength. And the question is, what will be the frequency of the light? So here, we can relate this to by using the wave equation, wave speed equation. And if we're going to calculate with the frequency, to rearrange this one, that will be just v divided by wavelength. Okay, our wavelength is 4.5 times 10 to the minus 7 meters. And speed, what is the speed that we're gonna use? Speed is not given, but there are two constant speeds that I gave to you. One is the speed of the sound in the air, which is 340 meters per second, and the other one is the speed of the light in the air or in vacuum. Okay, so the thing that you need to determine is this a sound or a light or electromagnetic spectrum? And we know that obviously that this is a light, so the speed that we gotta use for that one is 3 times 10 to the 8 meters per second. And if you calculate this one, you should be able to get the answer C. Okay, number 12. In a particular medium, a wave has a frequency of 120 Hz and a speed of 300 meters per second. So there's one medium, frequency is 120 Hz, and the speed is 300 meters per second. And the conditions of the medium change and the wave speed increases, so it changed to 350 meters per second. With the same frequency, so it means this, when the conditions change, the frequency will still be 120 Hertz. Okay, so the question is, if the same frequency is generated in a new condition, how much wavelength will change? So if you're going to calculate the wavelength, using this equation again, we can have V over frequency, which is 300 over 120 for the first medium. And then we will, if we calculate this one, our answer would be 2.5 meters. And then the second one, do the same thing, but this time is 350 divided by 120. And we're gonna get a wavelength of 2.92. Okay, and then what we need is, what is the wavelength change? So change in wavelength. So that will be change in. So 2.92 minus 2.5. We should be getting the answer of 0.4. Oh no, where is it? Oh yeah, it's right there. Letter C, 0.4. My letter D is on the other page, I guess. Okay, next. Number 13. A guitar string vibrates in a fundamental resonance of 110 Hertz. Okay, so 100, let's try yellow. If you have 110 Hertz as your fundamental frequency, the string can reproduce in the harmonic tones along this fundamental frequency. What will be the frequency of the fourth overtone? So fourth overtone. Okay, we know that we have this equation that any frequency is equivalent to the multiples of the fundamental frequency. First thing to check, is a guitar a node node or a node antinode or antinode antinode? We know that the guitar is a node node. So when you have this one, You can always refer to the table that we have. We know that a node is the harmonic number is 1 plus the number of overtone. So if we do have a fourth overtone and it's a node, then the harmonic number should be 5. Okay, by the way, this table is not given in your formula chart, it's not given to you. You should memorize the pattern. You should remember the pattern, okay? So going back to what we have right here, the frequency is the fourth overtone will have n equals to 5. It's 5 times 110 hertz, and that should be this 550 hertz. Okay, next number 14. You are standing next to a flagpole and notice that the rope that is supposed to hold the flag is vibrating. You, being a great physics student, notice that there are 3 antinodes along the ropes within the 2 ends. So if there's like a rope, there are 3 antinodes. 1, 2, 3. Okay, how many wavelengths is being produced as the rope vibrates? So it's vibrating like that one. Well, what is a wavelength? If we start here, one wavelength will end up here. So you have one wavelength and there is another half. So your answer should be 1.5. Number 15. An unknown tube has a fundamental frequency of 210 Hz and produces overtones of 840 Hz and 1050 Hz. Is the tube open on both ends or one end cap? Okay, so here you need to look at what is the pattern that it is doing. Okay, so you have a fundamental of 210 Hz, and then they said it's also giving you 840 Hz and 1050 Hz. Alright, so now using this relationship of the frequency and the fundamental frequency, we can calculate what will be the n that these 2 frequencies are giving. So if we arrange this equation for n is equivalent to the frequency divided by the fundamental frequency. So let's start with the 840 divided by the 1050 hertz. No, sorry. It's not. Fundamental is not 1050. The fundamental is 210. And this one will give you 4 and a 4. Okay, the next one. For the 1050, so you have 1050 hertz divided by 210 hertz. If you divide this, you're gonna get 5. Okay, so if you see, you have 4 and then 5. And again, if you're gonna look at the table that we have, in the harmonic number, the one that can give you 4 and 5 will be only either node or antinode, right? Because in the node antinode, it is only odd numbers. Okay, so going back to this one end cap, open both ends, then it should be open on both ends. Okay, number 16. You are designing a demo for the middle school exhibit on which you will show the sound of the tuning fork at 220 Hz can be amplified by a piece of pipe. You have several lengths of pipe and a tall container of water. What minimum length of the pipe would produce the resonance? Okay, this one we didn't, supposedly we're gonna have a demo on this one in class, but we weren't able to have the time. So let's say for example, you do have this big container of water. So this is water. And then there is a tube here. And you can submerge the tube, And then if you put a tuning fork here, it will resonate. Okay, it will resonate at it the the tube can amplify the sound. Okay, so the question is, what is the minimum length of the tube that you need to resonate? Okay, so first thing is we should know if we have this one, do we have both open, one closed, or both closed? Obviously here, if it's touching the water, this will be closed, and then here it will be open end. Okay, so now the length is related to the wavelength, and we know that if you have a closed end and open end, the formula for that one would be 4L over N, right? If it's both open or both closed, it will be 2L divided by N, but our alpha will be 4L divided by N. Now the lambda in the closed end or open end will be 4L divided by N. Okay, now how do we calculate this one first? We know that based from the wave speed, we have this formula. To calculate the lambda, it will be V divided by F. They said the speed is 340 meters per second, and it will be 220 hertz. We can assume that this is the first resonant because what you need is a minimum. So you can get the first the fundamental frequency. So if you divide this two, it will give you around 155 meters. Okay, and then you plug that in here, 1.55 for L, and the N is, it's a fundamental, it's 1. If you solve for L, the answer would be 0.39. Number 17. You produce two tones on your computer using a sound program. The first frequency is 310 Hz and the second frequency is 305 Hz. What will be the beat frequency that you will hear from your speaker? You know that the beat frequency is the difference between the two frequencies, right? So just subtract, then this will be equivalent to 5 Hz. Okay, I will not discuss number 18. Just look at your ISN page 52 to 53. We discussed the Doppler effect. And then this one, using a ruler to measure the amplitude and the wavelength of the diagram above. So you'll be using a ruler. You should know how to use your ruler. We know that when we calculate the amplitude, it's from here to here, or here to here. At any point, that is your amplitude. For the wavelength, let's choose a color and write this one. Well, let's put it green. Wavelengths, you can start anywhere. It can be from crest to crest, or if you start here, it should end up here. Okay, so when you measure using your ruler, you should be getting that the amplitude is 0.8 centimeters and the wavelength is 1.5. Okay, and now this one, I will not discuss this one, but look at your ISN page 53. Well, 52 to 53. Okay, that's it. Hope study well and we'll have a good test result. And by the way, study I sent page 48, which is the wave interference or superposition. You should know how to do it. Um, superposition. Should be able to do it. If you cannot do it, I have I created a video showing this one. It's this one. Okay. And if you still don't know what I'm talking about, it is this one. It is this one. Okay. It's a big part of your test. It's in the response. Okay. Good luck.